we have a little bit more left to cover in notes, so we'll cover those in notes, and then I will. We should have the remainder of time left to then. I mean, we're gonna wrap up notes today, and then we'll have. I need to look at when the due date is. I think the due date is like the Friday of Thanksgiving break, so I think I probably need to adjust that, or I'll have people going, "What kind of jerk / moron makes due dates right at the day after Thanksgiving?" So I will change that. I got to decide just how much I want to cover or where I want to put that. So I'll probably move it to after. But anyway, solve and graph the solution set for the real number line x squared minus x is greater than 20. So we're going to do inequalities with rational functions and polynomial. So let's talk about how we're going to do this. So our first step in doing this is we're always gonna want to compare this to 0. So we're going to subtract the 20 over so I can compare that to 0. Once we have that done, then we can go ahead and since it's set equal to 0, we can go ahead and factor that. So I can factor this into, to get x squared, we're gonna have to get x and x. We need to get, we have factors of 20, so that means we can use 1 and 20, 2 and 10, or 4 and 5, but our factors of 20 have to subtract. Our factors of 20 have to subtract to give me a -1. So that tells me that I'm going to have to use a -5 and a +4. So my solutions are 5, not a -5. My solutions are 5 and -4. Now, what we have to understand is this: when we solve, if this was an equal sign instead, we would be done. My two solutions are 5 and -4. But this is not an equal sign; it is an inequality sign. So that means things are going to change up a little bit. So we're going to have to figure out what happens. So we're going to go over here and we're going to create a number line. Here is -4 and here is 5. Okay, so what has happened is that has created intervals on my number line. I'm going to put an open circle there. Do we know why I put an open circle? My other option is a closed circle. Again, I'll grab this for online, but because this is greater than, the only thing I'm going to use is it doesn't have the equal sign underneath it. So that means we have open circles over there. So that's why we used open circles. Anyway, if I look at my number line, I have it created 3 different intervals for me. I have this interval that goes from -infinity to -4. I have another interval that goes from -4 to 5. And we have another interval that goes from 5 to infinity. So that's where those intervals are coming from. Okay. Now what we're going to do is we're going to go through something called a sign test in order to figure out which of those intervals are going to be my true solutions. So I'm just going to recopy the intervals. Probably I shouldn't have written them up there before, but for the first time through, I just wanted to show you where those intervals came from. But there are my intervals. I'm going to go back and again, I'm overkilling this problem a lot. Oh. Okay. Now we're going to do what's called a sign test. It's called a sign test because the only thing I'm worried about is the sign of my product. Okay. Now I need a number that's in the interval from -infinity to -4. I need some number that's in that range. And I'm going to choose -10 because -10 is in that range. Okay. Now we're going to put -10 into this first parenthesis. So -10 minus 5 is a -15, and I do not care about the 15 part of it. I'm just worried this is a sign test. So the only thing I'm worried about is the sign. We're going to put -10 in with this +4 here. -10 plus 4 is a -6. Again, I'm not worried about the value. I'm just worried about its sign. Now, when I multiply, because that's what it'd tell me to do, I'm multiplying 2 parentheses here. 2 negatives make a positive. So there we go. any number inside of that interval is going to create a positive solution. Let's pick something in this one. 0 is probably, I had a sign change, meaning from the left-hand side of -4 to the right-hand side of 5, I had a sign change. It went from negative to positive. So that means that 0 has to be in this interval. So I'm going to put 0 in for x, and I'm going to get a -5. I'm going to put a 0 in for x and get a +4. And now what a negative times a positive will give me a negative. Okay? Lastly, I need something in this interval from 5 to infinity. 10 is in there. So again, I'm going to put 10 into that parenthesis. 10 minus 5 is +5. And again, I'm not worried about the value. I just need the sign. So 10 plus 4 is 14. It's positive. So two positives make a positive. All right, big deal. Big whoop. We've done a sign test. What does that actually, how does that actually help us? Okay, so here's what we have to remember. Going back to the original problem, I want to know, when is this polynomial greater than 0? Now, what type of numbers are greater than 0? Positive numbers are greater than 0. All right, so what I'm left for is which one of these intervals, I have 3 intervals to choose from. Which one of these 3 intervals gave me positive numbers? This one gave me a positive number, so this is in my interval. This one did not. It gave me a -1, so that means this is not in my interval. And then lastly, this one was also giving me positive. So that means it's going to be in my interval. So my solution set is this. It's -infinity to -4. We're going to union that with 5 to infinity. Let us try another one. So the first thing we're going to do is always set it equal to 0. So we have to factor this. Now, typically, I could factor out something. I have 4 terms there. 4 terms screams factor me by grouping. So there we go. Factor me by grouping, please. All right, sorry, that was moronic. All right, here we go. In the first group, we share a x squared. So we're going to remove that x squared. I'm left with x plus 3. In the second group, they don't really share anything in common. However, there's a typo here. Oh, I didn't typo. I just did this wrong. I have to subtract it to the other side, so it should be a -3. So my mistake was when I subtracted the x over, I did that fine. However, when I subtracted the 3 over, I left that as a +3 so that it can roll. Anyway, both of those share a -1, so we're going to factor out a -1, which leaves me with x plus 3. And now we can see that both of these have an x plus 3 in common. So we're going to remove that out of both of those. So that leaves me with the x squared on the left. It leaves me with a -1 on the right. And when we do these, it is pretty much best if I put it into its complete factored form. So I have to recognize that that is the perfect squares. So that is going to be x plus 1 and x minus 1. And this is all still less than or equal to 0. We get -3, -1, and 1. Okay, so those are my solutions. So again, we have to figure out what intervals are created. I know that we have the equal to sign on this one. So that means we're going to have a closed circle at -3, a closed circle at -1, and a closed circle at 1. I have to figure out what 3 intervals just got created. So this very left-hand interval, it's going to go from negative infinity to negative 3. So that's what we're going to write down. Except I have to pay attention to it. I'm going to give that a bracket now because we're going to be in interval notation and we're including points. So my next interval goes from negative 3 to negative 1. My next interval is going to be this guy right in here. That's from negative 1 to 1. And my last interval is going to be from 1 to infinity. Okay, so this particular problem created 4 intervals, and I have to figure out which of the 4 intervals is going to be my solution set. Okay, so the same thing works, that same process. We're going to have x plus 3, we're going to have x plus 1, and we're going to have x minus 1. Those are my 3 factors. We have to pick a number that's in each interval. So I have to find some number that's between negative infinity and negative 3. We should be like the second page. Yeah, I think we're on that page there. Negative 10. I like using negative 10. So negative 10 is that's going to be a negative 7. This is going to be a negative 9. This is going to be a negative 11. So if I multiply together 3 negatives, that's going to give me a negative. Some number between negative 3 and negative 2. We don't have a whole lot of options here unless we want to work with fractions. So I got to pick with negative 2. That's going to give me a positive in the first slot. It's going to give me a negative in the second slot and a negative in the third slot. Okay, so do we understand why that's giving me positives and negatives? We're taking negative 2 and we're putting it in for x. Negative 2 plus 3 is a positive 1. Negative 2 in for x. Negative 2 plus 1 is a negative 1. Negative 2 in for x is going to be a negative 2 to negative 1, give me a negative 3. So a positive and 2 negatives is going to leave me with a positive. Negative 1 to 1. Again, we change signs from left to right. So that means that 0 has to be in there. That's going to be a positive. That's going to be a positive. And that's going to be a negative. So that's going to give me a negative sign. And lastly, we're looking at something like positive 10. So that's a positive, and a positive to give me a positive. All right. So from the last time we did this. Do I want positive numbers or negative numbers for my solution?
Negative.
We want negative numbers this time because my polynomial has to be less than 0. So numbers that are less than 0 are negative numbers. So that means that in my solution, this ended up being negative numbers and this ended up being negative numbers. So those are my negative numbers, and that means I do not want to include those two. So my final answer is from negative infinity to negative 3. We're going to union that with negative 1 to 1. Okay. Now, really fast, I wanted to show you the other way of solving this, just so you know what's happening. So we're going to tie this into what we were doing before. I want to graph. So I'm rewriting this. X squared minus x minus 2. I want to make a quick sketch of that graph. Okay. Now, actually, that's not minus 2. That's minus 20. I already have the zeros for this function. The 0 for this function happens at 5 and at negative 4. So out here's 5. Right here is negative 4. If I talk about my end behavior, just to refresh our end behavior, because this is squared, I know both hands go in the same direction. Because this is positive, I know that my right hand is up. So I know that this is going to finish with a right hand up and a left hand up. Likewise, just to remember graphing those functions, each one of these is a single root. So it's going to pass through and pass through. So there's a quick sketch of what that graph looks like. Now, why in the world am I drawing that the quick sketch? What does the quick sketch have to do with anything? What part of this graph that I just drew is above 0 or above the x-axis? So if I look at this graph, what part is above the x-axis? This part is above the x-axis, and this part is above the x-axis. Now, I know that looks like it goes up forever, but it also goes over forever, meaning this is from negative infinity all the way to -4, which was my first interval of my solution. This one went from 5 out to infinity, which is the second interval in my solution. So if we can graph, if you're a person that can graph relatively easy, or you can slap that into a graphing calculator, it makes things much simpler. So if I quickly sketch this graph, and again, it's more to refresh our memory on how to graph polynomials than anything else. There's -3, there's -1. Looks like I've got an y-intercept of -3, and then there's the 1 there. Okay? So again, remembering our rules for our wow, I don't know what I'm trying to do to you there. Stay there. I have x to the third. X to the third means that I have one hand up and one hand down. I have my leading coefficient is positive. So that means my right hand is up. So my right hand is up, my left hand is down. So that's what the end behavior makes my graph do. If I look over here, every one of my roots is a single root. It only appears once. So that means it has to pass through, and pass through. So that is a simple sketch of my graph. And again, I'm going to look for what did I want here. I want to know what part of this sketch was less than 0. So what part of this sketch was negative or below sea level, so to speak? So which part of this was underground? Well, this interval was underground. Well, that's from negative infinity to -3. That happens to be my very first interval. This is from 1 to infinity, which happens to be, excuse me, I'm looking for below, my bad. So below is going to be this one from -1 to 1. It's going to be below the x-axis. So that would be my second interval there. Okay? So we can solve an inequality by graphing, or you can throw it in your graphing calculator. We do have this one. It's an accidental one. We're going to make this much easier for ourselves. We're going to make that a 0. Same thing applies here. We're going to have critical values. So we're going to set 2x equal to 0 and find out that x is equal to 0. We're going to set x plus 1 equal to 0. So that means that x is equal to -1. Okay, so we have established then on our number line, my critical values are -1 and 0. So this one will be a little bit hard to test because we're going to have to test a fraction, but life will go on. We'll be okay. Okay, we're going to test there. We're going to test in there. So my intervals that got created, what one intervals got created here? We got from negative infinity over to -1. Now this had the bracket in there, so since this came from my numerator, we'll go ahead and bracket this off. My next interval goes from -1 to 0. Now I need to stop for a second because I goofed this up. If we go back to my domain restriction, what's my domain restriction here? What value causes my denominator to go to 0? -1 is going to be my evil Santa Claus here. All right, so that means that no matter what I do over here, x cannot equal -1. Well, I've screwed that up because I said x could equal -1 with that bracket. So that means I need to erase this. And we need to put a parenthesis in there because that interval is going to be there. However, x could be 0. That's no problem. So that gets a bracket. All right, so on my number line, again, -1 can't be used because -1 causes the 0 in the denominator. 0, however, is okay because 0 is just going to cause a 0 in my numerator, which is just fine. And now we're sign tested again. We're doing exactly what we did before, except now instead of worrying about a product, now we're worried about a division or a quotient. Okay, so we have 2x over x minus 1. So I'm going to use some number in this interval. Let's say negative 10. So that creates a negative on top, and that creates a negative in the denominator. Well, two negatives is going to make a positive. Okay, this one becomes the hard one. We're going to have to use negative 1/2. A negative 1/2. 2 times negative 1/2 is just negative 1. Negative 1/2 and a negative 1 make another. So that makes two negatives. That also is a positive. And lastly, I got to use some number between 0 and infinity. We'll use a 10. That's going to give me a positive and a positive, which is a positive. How does this, where have I gone wrong? They can't all be positives. All right, let's look at this graph and see where I went wrong. So we're going to graph this. I know we graphed last time. We graphed rational expressions last time, so you weren't here for this. We're going to have an asymptote here, that negative 1. So we're going to have a vertical line at negative 1, which means that my graph cannot touch that line. I know where my mistake is. Did y'all find my mistake? So we have x plus 1 right here, and I wrote this as x minus 1 right here. There's my mistake. Because now it makes sense. Because now when I come back here and I use this, a negative 1/2, a negative 1/2, and a positive 1 gives me a positive 1/2. And that becomes a negative. There we go. Now life is good. I had you all at hello. All right. Anyway, let's come back and finish graphing this line. So what we have is we have a vertical asymptote at my domain restriction. I'm also going to have a horizontal asymptote. My horizontal asymptote comes when x gets really, really large, it's going to approach a single number. When x gets really, really small, it's going to approach a single number, and that's what that horizontal asymptote is. So that's what we're going to do, is we're going to put a really big number in for x. So we're going to put 10,000 in for x. And if I do that on my calculator, 20,000 divided by 10,001 is 1.9998. So what number is that really, really close to? 2, very good. So there's a horizontal asymptote at 2. So if we look at my, I know I have if I want to find the x-intercept, I said this is actually a very complicated, solving these is complicated, but the x-intercept is when 2x equals 0, so that means that x has to equal 0 for that to happen. Or I could just put this on a graphing calculator. Those are my x-intercepts. So since there is no x-intercept over here, that means it has to exist up here. All right, so there's the graph of this. Now we're trying to, again, find what part of this graph is above 0. Well, what type of numbers are above 0? Positive numbers are. So we're looking at there for positive numbers. We're looking at there for positive numbers. So let's take a look at this. Wow, I made that hard to read. We said negative 10. So here is negative 10, and it was above the x-axis. We said 10 was. Well, we come out here, and 10 is above the x-axis. So that's true, and that is why my intervals for my solutions will be from negative infinity to negative 1. And we're going to union that with 0 to infinity, because those were my two intervals that created positive answers. When I did this negative 1/2 thing, negative 1/2, had a negative value. So again, that I didn't want negative values. I want positive values because I want to be above 0. Okay. A direct variation is going to have the equation of y equals kx. Fairly relevant, but here we go. The volume of blood in a person's body varies directly as the weight. So when it varies directly, that means we're going to, direct variation means we're going to multiply. Okay, multiply by constant. Now it tells me a person that weighs 160 pounds has approximately 5 quarts of blood. Estimate the number of quarts in a person that weighs 200 pounds. So that means that that ratio of body weight to blood, or blood to body weight, excuse me, is going to be 5 out of 160 as I divide that 160 over. So what is 5 out divided by 160? So that's 1/32. So if we're supposed to estimate what the number of quarts in a person weighing 200 pounds is, blood is equal to 1/32 times 200 pounds. So let's take that times 200. And that's 25 fourths, or 6.25 quarts. Okay, so we have to remember on a direct variation, we're going to multiply. Now, in reality, here's how it works. If we can set up a ratio, we can set up a ratio and be fine, meaning a person who weighs 160 pounds had 5 quarts of blood. I know the ratio is going to be the same in someone that weighs 200 pounds. So how many quarts of blood does that person have? So on a direct variation, we can actually set it up as a proportion should we choose. All right, that's the other thing to remember there. I struggle whether, because sometimes I think that leads to confusion. But on a direct variation, we can set it up as a proportion. So we're going to go with that one on the next one. A great white shark varies, the weight of a great white shark varies directly as the cube of its length. A great white shark was caught off Catalina Island, California. It was 15 feet long and weighed 2,025 pounds. What was the weight of a 25-foot-long shark in the novel Jaws? Now, what I have to remember here is it was the weight cubed, so I got to take the cubic weight. Now, how am I going to solve for x? We're going to cross multiply and divide, so we're going to have 15x is equal to 25 times 2025 cubed. So we're going to divide by 15 and divide by 15, and we're going to find out that the Jaws shark weighed holy moly. That does not seem right at all. Oh. There we go. I have to remember this is x cubed. So x cubed is equal to some large number. And then we have to cube root. So another 200 pounds. 400, almost 300 pounds. Ugh. So backing up a little bit, on direct variation, we can set up as a proportion. However, when we come down here to an inverse variation, we have to set this up with multiplication. So we have to have xy equals xy. Whereas on the other one, when we're doing a setup as a proportion, it's x over y equals x over y. Okay. Now we're going to multiply. So here we go. When you use a spray can and press the valve at the top, you decrease the pressure of the can, the gas in the can. This decrease of pressure causes the volume of the gas in the can to increase. Because the gas needs more room than it provided in the can, it expands in spray form to a small hole in the valve. Huh, did you know? I don't think I knew that, how a spray can works. So when you press the spray can, it decreases the volume in the can, okay? So it decreases the pressure in the can. So therefore, for everything to remain equal, it has to, it causes the volume of the gas to increase. There we go. All right, in general. If the temperature is constant, the pressure P of a gas varies inversely as the volume of the container. And actually, I digress. I don't think we need to set this up as a multiplication problem. I think we just need to set this up as it reads. So we're going to go back to this. Okay. In general, then, if the temperature is constant, the pressure P of a gas container varies inversely. So it sets up as a fraction as the volume of a container. So something that varies inversely means as one increases, the other one decreases. Okay. So the more I drive, so if I buy a pizza myself, okay, it's going to cost me $5 up front, $6, whatever Little Caesars charges now. Okay. However, if another person helps me out and goes in with me, now I'm going to only pay half that. Or if a third person joins, then we're going to pay a third. So the more people that join, the less I have to pay. That is an inverse variation. Okay. So it says the pressure of a container whose volume is 8 cubic inches is 12 pounds per square inch. So what we have to do is we're going to figure out this constant. I do something wrong with the constant because I have 12 twice. Whose volume is 8. So we know the volume is 8. So I gift that up. See, I gifted up again. So we have to get those variables in the right spot because that's what I evidently can't do right now. The volume is 8 cubic inches. So we know an 8 goes there. The pressure is 12 pounds per square inch, so I know 12 goes there. So if we have to multiply that 8 over to solve, we know K is going to be 96. So my equation is basically this. The pressure in the can is going to be 96 divided by the volume of the can. So it wants me, if a can expands to a volume of 22, what is the new pressure? So we know that the volume expands to 22. What is the new pressure? That's not what I wanted to do. I'm going to go back to Notability. Thank you. But I can't be back in Notability. I got to be back in Zoom. 4.36. All right. Is this our last problem? All right. The last thing on notes for this section, for this packet, for this chapter. The number of minutes needed to solve a college algebra 2 section 3.7 homework assignment varies directly as the number of problems. So the number of minutes needed to complete a homework assignment varies directly as the number of problems, and inversely with the students working together to solve said problems. It takes 4 people, so that's going to go in for S, 32 minutes to solve 16 problems. So that's what we have. We have to figure out what then my K value is. So I could go ahead and take that 16 divided by 4. 16 divided by 4 is 4. We'll divide that 4 out of there and we get 8. Okay, so equals K. So my constant is 8. So the number of minutes it takes will be 8 times the number of people working on the problem divided by the, by the number of problems divided by the students working on the problem. So in this case, we're trying to find out how many minutes will it take 8 students to solve 24 problems. In this case, your 8s cancel out and it's going to be 24 minutes. All right. So like I said before, this is it for notes. So we have the rest of the week and then the 2 days of next week. If you haven't heard or your other teacher didn't tell you now, the two days next week, next Monday and Tuesday, are going to be distance learning days. So you have the next week. Basically, you have the next 2 weeks then to finish up the homework for chapter 3. All righty, we're going to call that a wrap.